Good day, students. This is topic 2, lesson 2, transversals and parallel lines. So some of the learning targets that we're going to be focusing on today will be to prove theorems about angles and lines, and then use those theorems about the lines and angles to solve problems. So one question we should be asking ourselves is, how can we prove and use theorems about angles formed by transversals that intersect parallel lines? Well, first we have to establish a postulate about a pair of angles. That postulate allows us to prove a theorem about other pairs of angles, and then once we have those other pairs of angles, we can then use the postulate and the theorem to prove other theorems about other pairs of angles that are given within those lines and transversals. So let's look at example 1. It states that we want to prove that corresponding angles are congruent. So they give us that lines P and Q are parallel, and they want us to prove that the measures of angle 4, which is right here, and angle 8, which is right here, are equal. So the first thing that we can identify is that given the statement P is parallel to Q, we can see that angle 4 and angle 6 are pairs of alternate interior angles. We know they're alternate interior angles because they are opposite the transversal, and they are in between the two parallel lines. So using the alternate interior theorem, we can say that the measure of angle 4 is equal to the measure of angle 6. Now, if I look at angle 6 and angle 8, we see that they form a pair of vertical angles. We know they're vertical angles because they share a common vertex here and that they are opposite of each other. So using the vertical angle theorem, I can say the measure of angle 6 is equal to the measure of angle 8. Now, using the substitution property of equality, I can say that the measure of angle 4 equals the measure of angle 6, and then I can substitute the measure of angle 4 for the measure of angle 6. Because these two angles are equal to each other, I can replace one for the other. So because I'm replacing one for the other, here, if I replace the measure of angle 6 for the measure of angle 4, I can now say that my result is the measure of angle 4 now equals the measure of angle 8. And that comes back to what we initially wanted to prove, that these two angles here were in fact equal to each other, and we also know that these two angles are also corresponding. Example 2 says that we are trying now to prove the alternate interior angles are congruent. So once again, they give us that lines P and Q are parallel, and we want to prove that angle 3 is congruent to angle 5. Here on the side, we are given 6 different reasons that we can fill in our proof. Now, these reasons we can use more than one time. So the first statement that we have for number 1 is that line P is parallel to line Q. Well, that's obvious that the reason is given because it's stated right here in our problem. The second statement that we have here is angle 3 and angle 6 are supplementary. So as you can see, angle 3, let me erase this here so we can make that a little bit more clearer. Angle 3 and angle 6 are located here, and they're supplementary. If you notice, both of these angles are inside of the parallel lines, and they are on the same side. So the reason would be same side interior angles. So I've already used the given, and I've already used same side interior angle postulate. Number 3 states that we have the measure of angle 3 plus the measure of angle 6 equals 180 degrees. Well, if two angles equal 180 degrees, the sum equals 180 degrees, that tells me that is the definition of supplementary angles. And that is right here being used. Statement 4 says we have the measure of angle 5 and angle 6 are linear pairs. So angle 5 is here and angle 6 is here. So we see that both of these angles are on a line. And because both of these angles are on a line, we know that they are a linear pair. So because they're a linear pair, that's actually given. Okay, we can clearly see that in the picture. So we've used the given now twice. 5. Statement 5 says, angle 5 and angle 6 are supplementary. Well, we can see that that's clear as well because both of them are on the same line. And if we have two angles on the same line, we say that those two angles are called a linear pair. And that is the linear pair theorem, and that is stated here. Now, statement number 6 says the measure of angle 5 plus the measure of angle 6 equals 180 degrees. Well, if they are a linear pair, then that means that they have to be supplementary. So that is the definition of supplementary angles. So we've used that for a second time. And then number 7, statement 7 says the measure of angle 3 plus the measure of angle 6 equals the measure of angle 5 plus the measure of angle 6. Well, let's go back to what we had. In statement 3, we had these two angles equaling 180 degrees. And in statement 6, we have these two pairs of angles equaling 180 degrees. Because both of them equal 180 degrees, that means I can substitute one for the other. So that means I am using the substitution property of equality. Now, if I want to prove now that the measure of angle 3 is equal to the measure of angle 5, that means that I can get rid of one of these angles in both sides of my equation. I can balance my equation. So I can balance my equation by subtracting the measure of angle 6 from both sides. So that means in my last reason for statement 8, I am using the subtraction property of equality. And that is the last statement of the proof. So as you can see, we've just proved why alternate interior angles are congruent. Going back to our proof, it's stated here, angle 3 is congruent to angle 5 because we have here the steps and reasons for this proof. All right, looking at example 3, it says, given that line V is parallel to line T, so these two lines are parallel to each other, they tell us that the measure of angle 7, which is here, is 5x minus 29. And then we have the measure of angle 3 here, which is 3x plus 127. And they want us to find the measure of x. Well, first we have to identify what position are both of these angles in. So I have angle 7 and I have angle 3. Well, I see that both of them are on the same side of the transversal. And I also see that they're in the same position. One is on the inside and one is on the outside. So because they're on the same side of the transversal, and I see that they're in the same position, I know that these two angles are corresponding. So we're going to use our SSS solving system to set up an equation. So because I know that they're corresponding, I know corresponding angles are equal. So I can say the measure of angle 7 equals the measure of angle 3. And we know this by corresponding angles. I know they are corresponding. So because they equal each other, I can just go ahead and substitute in the values for each one. The measure of angle 7 equals 5x minus 29. And the measure of angle 3 equals 3x plus 127. And my last S, as we all know, is to solve. So I'm going to subtract my 3x on both sides. That leaves me with 2x minus 29 equals 127. And then I'm going to add 29 to both sides. So that leaves me with 2x equals 156. And then I divide both sides by 2. So that leaves me with x equals 78. And ladies and gentlemen, that is my answer for example 3. Looking at example 4, I have lines P and Q are cut by a transversal, and they tell me that the measure of angle 1, which is here, is 7x minus 36. and they tell me the measure of angle 2, which is here, is 5x plus 12. And they also tell me that lines P and Q are parallel when x equals what value. So once again, I can use my SSS solving method, and I see that angles 1 and 2 are inside of the parallel lines, and they are on the same side. So because they are inside the parallel lines and on the same side, I know that these two angles are same side interior angles. If we remember from our notes, same side interior angles means that the two angles add up to equal 180 degrees. And that is same side interior. So now I'm just going to substitute the values of both these angles at 7x minus 36 plus 5x plus 12 equals 180 degrees. And now we're just going to combine like terms. So I have a 7x and a 5x, and I have a negative 36 and a positive 12. So when I combine like terms, I get 12x minus the 24 equals 180. And then I'm going to go ahead and add 24 to both sides. So I get 12x equals 204. And then I'm going to divide 12 on both sides. So I have x equals 17. And ladies and gentlemen, that is our answer for number 4. All right, ladies and gentlemen, let's look at the last example, example 5. In the accompanying diagram, parallel lines AB and CD are intersected by the transversal EF. Now, they want to know if the measure of angle AGH, which is here, equals x plus 15, and the measure of angle GHD equals 2x, which is here, which equation can be used to find the value of x. So if we look at these two angles, we have to determine what position are they in. So I see that the two angles are in between the two parallel lines, and I also see that the two angles are opposite of each other. They are on opposite sides of the transversal. So because the two angles are in between the two parallel lines, and they are opposites of the transversal, I know that these two angles are alternate interior angles. So what do we know about alternate interior angles? Well, I can write a congruency statement. I can say that angle AGH is congruent to angle GHD. Because these two angles are congruent, because we know alternate interior angles are congruent, I can also write an equality statement. The measure of angle AGH equals the measure of angle GHD. Because these two angles are equal, that means the measures of those angles are equal. So that means I'm just going to equal the two values of those angles together. So which of these statements show the values of these two statements equal each other? Well, there's obviously some I can eliminate. I can eliminate this one because these are adding the two angles together to equal 180, and we know that would represent supplementary angles. This is adding the two angles to equal 90, and we know that represents complementary angles. And this has some weird multiplication equaling 0 thing going on. So we know that's not it. So obviously the first one has to be true because we have the two angles equal to each other. Well, ladies and gentlemen, that concludes our class notes lesson for today. Please make sure that you are reviewing the warm-up activity in your OneNote class folder. And as always, I will review the vocabulary terms and the class note workout problems during our virtual class session. Good day, ladies and gentlemen, and see you soon.